Welcome to the project demonstration of transformer health monitoring system by using Blynk application. So in this version we added the Blynk application. The previous version we did that using ThinkSpeak cloud platform. So there we can store the data. Now we are going to get the live data along with alert notification. So if is there any abnormality detected, then the same abnormal message will be displayed on the LCD screen and the buzzer will get switched on. And the next same alert notification will be sent to the Blynk application through this ESP8266 Wi-Fi module. So here the parameters are like we are monitoring currents. First one is the current and the voltage and the temperature from this LM35 and frequency from this PC817 optocoupler and oil level with help of this SR04 ultrasonic sensor which can monitor the surface of the oil. So these 5 parameters continuously monitored by our PIC16F73 microcontroller. So coming to the abnormal conditions, if the current is above 200 milliamps or if the voltage is below 180 and above 240 is abnormal condition. And next frequency if it is less than the 45 Hz and temperature if it is greater than the 50 degrees centigrade and oil level is if it is less than the 70%. So these are the abnormal conditions. And coming to the interfacing connections, so we have interfaced this sensing board along with ultrasonic sensor. Sensing board is connected to the A0, A1, A2, A3, A4 pins and ultrasonic sensor at C0, C1. So based on this inputs, our controller will monitor that and display the data on the LCD screen which we have interfaced at pin number B2 to B7. And next, based on the abnormalities, we are going to control the load by using this electromagnetic relay which was connected at pin number C7. And also buzzer will get switched on which was connected at the C4 pin, and the data will be uploaded to the Blynk application that through this ESP8266 Wi-Fi module, so which was connected at B0 B1 pin. So let us see the power flow. So we are providing 230 volts AC input to this transformer. So in real time we can monitor the 1:1 transformer, but for demonstration purpose we are using the 230 volts to 12 volts AC, that is 2 amps transformer. So in order to measure the frequency, that AC is directly given as input to the PC817 optocoupler. There we are going to count the number of pulses, means how many of hertz frequency we are getting that. So that will be counted by the microcontroller from this PC817 optocoupler. And the next, oil level. So coming to the ultrasonic sensor. So here we can see the ultrasonic sensor consists of 2 modules, and so one is a transmitter and there is a receiver. So whenever the transmitter transmitted the ultrasonic waves, if is there any object placed in front of that, whether it is a liquid or a solid, so the surface of the object will reflect the transmitted ultrasonic waves and that will be received by the receiver module. So based on the transmitting speed, as we know the sound speed, and next time will be calculated by the microcontroller, means once the transmitter signal, it will receive that if the obstacle places. So the speed into time, so in how much of time it will receive the data, the signal, echo signal. So the speed and time we will get the distance. So if the distance is less than the 7 centimeters, like that we are calibrated that 0 to 10 centimeters as 0 to 100%. So based on that we are going to calculate the oil levels from this PIC microcontroller. And the next we are providing the main operating voltage from this adapter. So we are providing 230 volts AC to this adapter which will provide us the 5 volts DC output, as it has the stages of 4 stages. One is the transformation to step down the 230 volts AC to 12 volts AC in this one, and the next rectification to convert the AC to DC, and filtration to remove the pulses to get the pure DC voltage, and next regulation to provide the 5 volts as the operating voltage of total input and output modules is a 5 volts. So for that purpose we are going to regulate that to 5 volts, and once we provide that to the microcontroller, it start reading input from the input sensors and control the output modules. So let us see the demonstration. Before on the kit we need to set up some steps. So install the Blynk application which we have provided and log into the Blynk application. So this screen will be seen. So if it is shown like this, click on that only, don't click on stop button. So it should be always like this only. And next we can see the red icon over here which will show the status of the device is offline. Right, after this app setup, now go to hotspot settings of your phone, change the hotspot name to So right, go to hotspot settings and change the name to project project 5712 and password should be 123456789 and AP band should be 2.4 gigahertz. So these three are very important. All are small letters without any space. Project 5712 and password 129 and 2.4 gigahertz. Then after on the hotspots there you can see 0 device connected. Now on the power supply for the transformer as well as for the our main motherboard. Right, the transformer gets switched on. So this board will show the status of transformer whether it is on or off, and everything is normal. The bulb got switched on and we can see one device is connected over here. And now go to the Blynk application. Now we can see that the device is online now. So now I am changing the oil level. Let us see that. Okay, and now so when it is below 70%, you'll get the alert notification. Low oil level, the bulb will get switched off. So it still keep on sending the alert notifications. Right, and coming to the voltage and current. So this is the current. I'm going to increasing the current. Right, high current, same high current notification will be sent. And voltage, normal and low voltage. So clockwise increasing the voltage and anti-clockwise decreasing the voltage. And coming to the frequency, so just unplug this wire. So you can see that the frequency is 0 now. So we will get the alert notification. So you can connect this here. So you can connect that in any direction as we are providing the AC only. And the next, temperature. So in real time we are going to place this on the transformer like this. For demonstration we are heating the temperature sensor manually. So it increases and we get the same alert notification. So this alert notification can be accessed from anywhere in the world. So you just on the hotspot near the kit and leave the kit, and you can log into the Blynk application in any mobile phone which has the data. So that can be accessed from anywhere in the world, and you will get the notification alerts also from anywhere in the world directly.